Welcome everyone to our second video in the series of basic math operations for ICT and networking students. And today we're going to be talking about decimal to binary, binary to decimal conversions. If you haven't watched the other video that talks about the powers of a number, please make sure you come back and watch it before you move forward in this video. So Um, like I said, we're just basically interested in the powers of the number 2, and that's because we are mostly studying computers, and computers, they mostly understand binary numbers, so two values, zeros and ones. So we are particularly interested in the powers of the number 2. And now we're just going to basically learn how to calculate and how to convert a binary to decimal number and a decimal to binary number. Okay? So basically, in order to do this, so there are many ways to do this. Some people, they like to do this by taking a decimal number, for example 255, and dividing it by 2. Okay? So they divide this number by 2, check the reminder, and then they keep dividing the number by 2 every single time until they finish it up, until they find a 0 or a 1, and then they just basically take all of those reminders, and those reminders just represent the binary uh, version of the number. Now for us, basically interested in calculating IP addresses, network addresses, subnet mask, which is just basically the main purpose of this course. We are just going to be doing into a very particular way that actually makes the calculations a little bit faster. So in order to do this, and for all your networking and IT career, we're mostly interested in the numbers and the powers of numbers from 0 to 7. And why is that? That's just basically because the powers of 2 from 0 to 7, they are very special because they are involved in the IP addressing calculations, subnet mask calculations, and so on and so forth. So basically, we're always going to see these numbers, we're always going to see these powers of 2, and the easiest way that we can convert binary to decimal numbers, decimal to binary numbers, is by taking each one of the powers of 2 from 0 to 7, writing them down in reverse order. So we start from right to left. So 2 to the power of 0 equals 1, 2 to the power of 1 equals 2, 2 to the power of 2 equals 4. Now, if you don't know what these numbers are representing, please make sure you go back. I have a video explaining about the powers of the number 2. So what's the main purpose here? We just basically need to take these powers of 2 in order to convert these decimal numbers on the left into a binary series of numbers. They're going to be represented in this table here. Okay, so let's start. Let's begin. So the number 255, how are we going to convert this number 255 in a series of binary numbers? So a series of zeros and ones, they're also going to represent this number. So it's a very easy step to do, very simple. We just need to take the number that we're interested in this case 255, and start dividing it by each one of these. Okay? So we need to make sure the 255 is divisible by each one of these numbers. If it's not, we're just going to select a 0, and that is because this specific number is not used in order to compose these number. All right, so let's do a few examples, and this is going to be clearer to everyone. So 255. How do we convert 255 into a binary series of numbers? So let's do this. It's a very systematic approach. Once you put this table in order, you start from 2 to the 0 up to 2 to the 7 from right to left. You start dividing 255 by the very first number, or the very highest number that we have in the series of powers of 2. So 255, can we divide 255 by 128? If the answer is yes, and it's very, very simple to determine this, it's just by knowing that 255 is greater than 128. If it is, we can just basically divide it. Um, so 255, can we divide by 128? And the answer is yes. Okay. And by dividing it, I mean the result will be greater than 1. So 255, is it greater than 128? Yes, it is. So this is the first answer we have. So we're going to need the number 128 in order to write down 255 in binary. So we just basically need the number 1 here to write 255. And this number 1 here just basically means that 1 times 128 plus all the numbers that I will find out. So once I know that 255 divided by 128 is going to be 1, I need to know the remainder. And it's simple. I just need to take 255 and subtract 128 because now I already have 128. And once I do that, 255 minus 128 is 127. So I just need to carry the 127 forward now to all the other powers of numbers. So now that I have 127, I need to take this 127 and divide by the next one, which is 64. And when I do this, I have 1. So I need the 64 to write down 127. And then what I do is 127 minus 64, 63. I carry out 63 to the next one. Now 63 minus 32. So can I divide 63 by 32? Yes. So basically, if I do this, I need 32 to write down 63. So the special number I need to put in here is a 1. Now 2 to the power 4 is 16. Now what do I have left? So when I got here, I had 63. Now 63 minus 32 is 31. Now 31 I will carry forward. 31 minus 16 will be 15, or 31 divided by 16 is going to be 1. Remainder is 15. So I'm going to go forward, and now what do I have here is I have 15. 15 divided by 8 is 1. Okay, if I know that it's 2, 2 is going to be greater than than the number that I need, because 2 times 8 is 16, but I only need 15. So 15 divided by 8 is 1, and the remainder is 7. So I can put a number 1 here. Now what do I have left? So I had 15 minus 8. Now I have a number 7. 7 divided by 4 is 1, and the remainder is 3. So I need a number 1 here. And what do I have left? I have a number 3, because 7 minus 4 equals 3. Now 3 divided by 2 is 1, and the remainder is 1. So this is going to be 1, and I'll carry forward the number 1. So 1 divided by 1 is 1. Okay, so what do I need to put in here? It's a number 1. And now that the remainder is 0, I can just stop, and I need everything. I have everything that I needed. So basically what this means is that 255 in binary notation equals to a series of 8 number 1s. So I'm just going to do something here, and I'm going to represent these number right here. So this is just basically 8 number 1s. 1, 2, 3, 4, 5, 6, 7, 8. Just going to write down binary sequence, and there you have it. So 8 number 1s is a binary sequence that represents 255. Now let's move forward and calculate the power. What's the binary version of 128 decimal? So 128, so I start with the number and divide by the highest one, the highest power of 2. So if I divide 128 by the highest power of number 2, in this case, which is 2 to the 7, is going to be 1. Now, 128 divided by 128 equals 0. Okay, there's no remainder. Okay, if I divide it, it's 1 because I need 1 times 128 to have 128. Now the remainder is 0. Now that the remainder is 0, I don't need any other number, any other power of 2 to represent this number. So that pretty much means everything else is a 0. Okay, and the binary sequence here will be 1 and followed by 7 zeros. 1, 2, 3, 4, 5, 6, 7. Now let's do 64. 64 is a special number, so I just need to divide 64 by the highest number that is actually equal or lower to 64. Now, 64 divided by 128 is not a division that's going to be greater than 1, so that just basically means it's a 0. I don't need 128 to write down 64. Now I move forward because I wasn't able to divide 64 by 128. The remainder is still 64. Now I take these 64 and divide by 64, and that's just basically 1, and the remainder is 0. So everything else will be 0. Okay? Now the binary sequence that represents 64 is just basically 0, 1, followed by 6 zeros. 1, 2, 3, 4, 5, 6. Okay? Just going to put a number here. Just going to change this to a text. And there we have it. That's the number that we are interested in. Okay? Now let's move forward to 92. So 92 is not divisible by 128. So we cannot divide 92 by 128 and get a number that is greater than 1. And for these reasons, we don't need 128 to write down 92. So it's going to be a 0 here. Okay? Now 92, if we divide by 64, is going to be 1. And the remainder will be 32. So we're just going to write down 1. And now that the remainder is 32, I carry this 32 forward. And now I have 32 divided by 32, which is just basically a 1. And the remainder is a 0. So it's 0 for everyone else. All right. So the basic binary sequence that represents 92 is 0, 1, 1, 1, 0. So 5 more zeros. 1, 2, 3, 4, 5. Okay. Now that we know exactly how to do this decimal to binary calculation, and we know the uh, what we need to think about when doing this, I'm just gonna change things a little bit, and now let's try to do the opposite. So when you have the opposite and when you're giving the binary sequence and you have to find out the decimal value, it's an actual simple process. So I'm just going to erase all of these numbers that were here before. And now I'm going to put some numbers here in the binary sequence. And we're going to have to find out the decimal value. So for example, if you have a sequence of 6 zeros, 1, 2, 3, 4, 5, 6, followed by a sequence of 2 number ones, what is the decimal value of these sequence of binary values? So we just basically need to populate the table following the same order that is given. So basically you can start from right to left, or left to right is up to you. I'm going to start from right to left. So I just basically have a 1 here, a 1 here, and all the other numbers are zeros. And what do I do now in order to find the decimal equivalent of these binary sequence? Is just basically taking every single number and adding them up until I find the number I need. So here we have a number 1 in 2 to the power of 0, which is equal 1. So it's going to be 1 plus the second one, which is 1, is a number 2. So 1 times 2, 2. 2 plus 1 is 3. So that's the decimal equivalent. All right. Now let's do a different one. A sequence of 7 number ones, 1, 2, 3, 4, 5, 6, 7, and the 0. So let's just populate this table. It's going to be 1, 1, 1, 1, 1, 1, and a 0. This is just basically, now let's start from left to right. It doesn't really matter after you populate the table. So it's going to be 128 times 1, which is just basically 128, plus 64 times 1. So this is going to be 192 times 32, 224 times 16, 240 times 8, 248 times 4, 252, plus 2 times 1, 254. Okay. Now let's do a few examples more. Just gonna have this number here. So it's 1001 followed by a sequence of 4 zeros. Let's just populate this table. This is just going to be 128 plus 16. So 128 plus 16 is going to be equal to 144. Okay, is this clear? Let's move on to the second example. So 1 0 1 0 1 0 1 0. How do we do this one? Same way. It's going to be a 0 1 0 1. Okay, now I just need to add the values that are 1. Okay, so this is going to be 128 plus 32, which is 160, plus 8, 168, plus 2, 170. Now how about the next one? 0, 0, 0, 0, 10, 10. So it is 0, 0, 0, 0, 1. So this is going to be 8 plus 2. This is a number 10. Done. Now you know exactly how to do a binary to decimal and decimal to binary conversion, which is going to be extremely useful for us when we start studying IP addresses, subnet masks, network addresses, and broadcast addresses. Thank you very much for coming, everyone, and I'll see you in the next series of videos.